So there has been a piece of science communication artwork, I would call it, that has been going viral for some years now. And I want to take this opportunity to talk a little bit about what can go wrong with this kind of artwork. So, back in 2016, Randall Monroe, otherwise known as XKCD, an author of a viral or very popular online comic strip, published a world temperature record going back 22,000 years ago. So let me just describe how this comic looks like. So it's essentially a time axis spanning from something like 20,000 BC to today, and then into the future to the year 2100 on the x-axis. And on the y-axis, there's a temperature anomaly, so the global temperature anomaly, um, spanning from like minus 4 degrees C to plus 4 degrees C. And so it's a
All right,
very
wait, can I try describing it? Just
yeah,
because
sure.
I think some people might be able to get that, but I'm looking at it right now. And by the way, a friend of mine in San Francisco, Alex Lloyd, has asked me twice now to comment on this. So I figured, okay, let's cover this. And I thought Steffen has a lot of good perspective on this, and I have some thoughts as well. So it starts out at the top. It says a timeline of Earth's average temperature since the last ice age glaciation. And then it says, when people say the climate has changed before, these are the kinds of changes they're talking about. So, what it's the overall idea is to show unprecedented climate change recently. And, they're trying to counteract the idea that, well, climate is always changing. They're trying to show, well, no, recently there is an unprecedented climate change, or at least you know, an unusual kind of climate change. But which, by the way, it's totally possible to think that and to still think that that change is completely manageable as long as we have a lot of energy production and a lot of freedom. And that's going to be one thing that's left out of this, is that it's just totally focused on the side effect that is climate change is also distorting that, but it's not focused on what's happened to human flourishing during this time of climate change. Because you can imagine something that would be like, oh, here's a timeline of medical side effects in the last 20,000 years. And oh my gosh, there's been a real proliferation of medical side effects in the last 100 years. And the medical side effect, intergovernmental panel on medical side effects projects even more unless we dramatically reduce the causes of medical side effects. You think, well, maybe it's good that we have an increase in medical side effects because we have an increase in the use of medicine, and maybe that has a big impact on human flourishing. So that's going to be here. But just to show you, so what happens is, at the top, what you see is it says temperature, and then on the far left, it says -4 degrees Celsius, and it goes to 0, and then it goes to 4. And the -4 has a kind of blue to it, and the kind of a light blue, and then the +4 has kind of a red, which people I think like red because it's a little alarming. Although this isn't nearly as alarming as many reds that are being used. And so what you see then is you go down this, and it starts at 20,000 BC, and then it goes in 500-year increments. So it goes 19,500, and then 19,000, it's et cetera. They go BCE, before the Common Era, so which is the same as BC, but people like to use BCE sometimes. So they're going down, and basically what you see, it starts at, so the anomaly, I should just say, is the anomaly is like the difference. It's like how different the average temperature is from our average temperature today. So in the middle is 0, and they're taking it between 1961 and 1990, which is interesting why they take that as the number. But so they're starting at something like -4 and a third. So they're showing, okay, it was really cold back then. And then you can imagine, it's going to start warming up at some point. And so as you go down, they have a bunch of different events and stuff. And I'll let Stefan fill in some details. But in general, you have the thing going slowly to the right. And then near 1500 BCE, it goes faster to the right, interestingly. And then they're showing it goes to the right. And then at like 11,500, it starts going to the left. So it starts getting cooler again. And then it starts getting warmer at 10,500 BC, and it gets actually quite warm. I mean, it's pretty significant. So it's developing farming, and through 9,000, it keeps getting warmer. They start to uh, cross past zero, and then they keep going. So like 8,000 or 7,500, it kind of stabilizes for a while. There's like little cooling, little warming, but it's staying. You're seeing it stable for like 8,500 years, and then it's sort of cooling a little bit as you get to the year zero. And at the year zero, it kind of is at zero, like the temperature anomaly is zero, and then it gets a little bit cooler. But it's staying pretty steady for 8,000 plus years, and then it gets cooler after 1,000, which is going to be an interesting thing because there's some medieval warm period that was widely acknowledged. And so basically it's getting cooler until about 1850. And then what's happening is it starts getting warmer pretty dramatically through through maybe 1960 or 1970. And then you see this significant thing where it's now going up into the, 1 degree above. And so what you're seeing a more, well, you're sort of seeing a more dramatic increase than you've seen in the past. But then in particular, what you're seeing is, now granted, they put this in dotted lines at the end, but then you see a really dramatic warming in the future. And it says current path. So it's like the current path says, wow, we're going to get warm really, really quickly. Like we're going to go into this territory that seems unprecedented by 2100. And then it says, okay, the best case scenario is that it'll level off, assuming immediate massive action to limit emissions. So what you see is then it stops warming altogether pretty soon. And then by 2100, it's not that much warmer than it is now. And then there's an optimistic scenario, which the warming is less, but still quite dramatic in this. And then current path. So hopefully that give you some indication. Of course, you could just look at this. We should put a link to this, but it's at xkcd.com. And so the idea is, yeah, there was a bunch of warming and cooling in the past, but today's is really unprecedented, and we are heading in a really bad direction. And so we should probably do this best case scenario. So I have some thoughts, particularly on the labeling of best case scenario, which I would not regard as a best case scenario. But Steffen, what did you want to say about this?
Yeah. So one thing that strikes everyone who looks at this is at the very end. So the modern era looks so much different because it changes so sharply in one direction, and it really, if you look at it, so this is a very lengthy image. So you scroll through the thousands of years for a lengthy amount of time, and then suddenly this big spike comes up. So this sort of is intentional to give you the impression that this is totally unprecedented and a total, like, almost 90-degree switch in rapidness of the warming. And so one feature of this lengthy line is that it's sort of very smooth, and it wobbles around, and it's very gradual in its changes. Like, even if you see temperature changes going from -4 to 0 and then up again a little more, that is over very lengthy periods on this time axis, and it's very smooth and doesn't change quickly at all. So it changes gradual, and it's just the magnitude comes with the length of time. And towards the end of that graph, it's really, really a very fast-paced change. And so this is suspicious. And so what's good at XKCD is that they give an explanation file and give the sources and so on, so people can look things up. So, and what you find is that, yeah, for a lengthy period of time, so they use proxy data, right? So they use some data they derive from papers that use proxy data. So this is, for example, tree rings or clam shells in sediments or ice core data that sort of gives you an estimate of what historic temperatures might have been. And that is then glued together end of the 19th century with the modern thermometer record, right? So this is the first time when sophisticated nations started to systematically get temperature records, and from that you can estimate better and better the global temperatures. in real measured form instead of deriving it indirectly from proxies. And then at the end, of course, it's glued together with IPCC predictions of future warming scenarios. And so the sudden change is quite problematic because, and this comic, of course, created some media echo and then was discussed by experts. And one of the problems that turned out is that the authors of the papers for the proxy data then said, okay, yeah, we don't actually look at the question whether this is a really rapid change. And one of the problems is that our proxy data on average smoothes 120 years in the temperature record. And what that means is that you essentially get an average value for a very lengthy period of time, over a century, for most of this graph. And then when the modern temperature record comes, it's smoothed a little bit in this comic strip, but it's actually a much shorter period of time. So naturally, just because of the mathematics involved from the smoothing or from the actual data record, the temperature shifts before the modern thermometer record cannot shift that much in a time period. So there could be wild swings in reality, historically, that we cannot see in the sediments. We just get an average value over a lengthy period of time. So maybe there was a much more rapid warming. We know, for example, that, or we have a really good idea of that there was a Minoan warm period, a Roman warm period, medieval warm period, and so when the Vikings settled on Greenland and so on. So we have some idea of changes that took place at a relatively rapid pace, not in human terms, but in geological terms. But you cannot really see that in this proxy data. And this was just simply then glued together with the modern record, which shows more, short period rapid changes. And then, of course, the climate predictions, that's not actually data, that's somewhat speculative. And another problem I have with that is that you don't see any indication of uncertainty. You get a dotted line and a full line and then a dotted line again, but nowhere in this is an indication that, oh yeah, this could be temperature 0 degrees, or it could also be plus minus 2 degrees or something like that. You would normally in the data, you would see at least some indication of uncertainty. You don't have that here with any of the data sets. It's just a straight line. And it looks like, oh, we know precisely what kind of temperature we had, in 1000 BCE. And that's not true, of course. And then again, towards the end of that, we don't see any indication of how uncertain actually the predictions are, the projections to the year 2100, right? So these are model calculations. And one of the things that you only know if you've seen the model or the model outputs before is that there are actually different models that predict vastly different things. Like there can be a difference of 2 to 3 degrees centigrade between single model outputs for a certain emission pathway. So, there's some uncertainty for sure there, but there's no indication of that. It's just they take the mean and then plot it and say, oh, that's what science says. And that gives you a very false impression of what we actually know and with what kind of precision we know. And that's some of the problems. So it glues together data that is not really compatible and makes no real indication that there's a difference between them. Then the smoothing isn't, well, it's alluded to in the comic. There's some, oh yeah, this proxy data actually smooth things, but only the really extreme spikes, or only the slight spikes would be smoothed out, which is not true. 120 years of average temperature, think about what the average temperature would be if you would just average the entire thermometer record. It would be totally no change for the last 120 years since the beginning of a modern record. And vague IPCC reference, no indication of uncertainty there, no indication of different models tell different things, and yeah, so this gives you the final impression that, oh yeah, we know precisely what temperatures were in the past, what they are now, and what they will be in the future if we don't do X. And the comic strip itself says specifically, yeah, this comes from fossil fuel CO2 emissions, and that has created this warming in the late 20th century.
All right, so let me. Those are some really interesting details. Let me just give my summary of what's going wrong with this. So I think of this as these kinds of infographics or info cartoons. What they're trying to do is give us perspective on something that's important to our lives, and I think they can be very, very valuable. But I think this has at least three huge problems with it. So one is it's just focused on the side effect of something that's incredibly beneficial, namely fossil fuel use. So, fossil fuel use, the fossil fuel industry has given us and continues to give us this unprecedented energy production that allows us to use machines to improve our lives on an unprecedented scale and make possible a way of life today that's completely unprecedented, at least for the billions of people who have it, and then there are billions of people who want it and who don't have it. So you have to. It's distorting to just look at the side effect of a profound value, but not look at the benefits. So that is, I'd say, the most fundamental distortion. But then within representing or misrepresenting the side effect, it misrepresents the past. And in particular, it misrepresents how stable and smooth the phenomenon related to the side effect is. So, as in average temperatures. And it's misrepresenting them as far more stable and smooth than they are. So that's going to then give us a distorted sense of the side effect so far. And then I actually think it even in terms of like the side effect, insofar as it is a side effect in like the last 200 years, I think that is not, there's not enough precision there. But then the biggest thing is, so you're misrepresenting the past. That's point two of the side effect, and then, or the area related to the side effect. And then the other thing is misrepresenting the future, acting as if you have a large amount of confidence that a certain kind of prediction will hold true. And so that is a real distortion. So when I look at this, it gives you this idea of, oh, wow, well, this is a real problem. Like we're facing a real problem because this force in our lives is dramatically changing our climate in unprecedented ways. And so you have a much more dramatic picture of what has happened, and then even more dramatic and inaccurate prediction of what will happen. And you have no context of the benefits. So I do think it's a pretty good analogy to think about like medical side effects. And if you were to look at that, you would surely see, oh yeah, well, those are generally increasing. But if you just had that, let alone if you misrepresented it with the kind of distortions that XKCD has and the particular papers he's relying on, have, then you'd get it even more. But the biggest thing is can't look at the side effects apart from the benefits.